Hello students, let us solve a problem from NEET UG Paper 2019. Here is a problem. In this problem it is stated that a block of mass 10 kg is in contact against the inner wall of a hollow cylindrical drum of radius 1 meter. The coefficient of friction between the block and the inner wall of the cylinder is 0.1. The minimum angular velocity needed for the cylinder to keep the block stationary when the cylinder is vertical and rotating about the axis will be square root of 10 radian per second, 10 by 2 pi radian per second, 10 radian per second, or 10 pi radian per second. You have to find out the correct one. So let us first understand the problem, and I have got a simple diagram for you over here. So this is the hollow cylinder, and suppose the block of mass m is this one, which is sticking or in contact with the inner wall of the cylinder. Now the cylinder is rotating about its own axis, suppose with an angular speed omega. Okay, so at this condition, if we draw free body diagram, look, there are 4 forces acting on this block. One is the frictional force. When the block is sliding down due to its weight, the frictional force will come into the picture, and that will be acting against the weight. So weight is downward, friction is in the upward direction. Suppose this friction is a limiting friction. That's why it is written as FL. Now, since the block is rotating with the cylinder, so it will experience a centrifugal force that is away from the center of the circular path through which it is rotating, and that is given by mr omega square. This is the centrifugal force. With this force, when the block will press the wall, inner wall, the wall will give the normal force on the block. Now the thing is that if the block has to be stationary, then the normal force exactly has to be equal to this centrifugal force m omega square r, so that there will be no motion in the horizontal direction, and to not have any vertical motion, the limiting friction must be greater or equals to the weight of the block. Hence we get at equilibrium FL greater or equals to mg. FL is the limiting friction, and we have seen the normal force is equal to m omega square r, so that there will be no net force acting on the block, and hence it will be stationary with the cylinder. So we know FL, limiting friction, can be written as mu into n. Mu is the coefficient of friction and n is the normal force. So we have written over here, so mu into n greater than or equal to mg. So n is m omega square r. We put it here, so we get the condition that the block will not be in motion, or it will be in stationary condition when mu m omega square r is greater or equals to m into g. Now we have to find out the minimum angular velocity needed for the cylinder to keep the block stationary. So we can find out the minimum angular velocity from this relation. So minimum angular velocity will be equal to square root of g by mu into r. So g is given as 10 meter per second square, mu is 0.1 and r is 1 meter. So if we put all the values and do a little bit of simplification, we get that the minimum angular speed will be 10 radians per second, and hence the third option will be the correct answer for this question. Thank you.